Grounding in electrical systems is crucial for safety and proper operation. When working with metal electrical boxes, one common method for grounding involves the use of grounding screws. These screws are specifically designed to provide a secure and reliable connection between the grounding conductor and the metal box. The purpose of grounding is to create a low impedance path for fault current to return to the source, which helps to trip a circuit breaker or fuse and quickly to energize the circuit in the event of a ground fault. This prevents dangerous voltage from appearing on the metal enclosure, reducing the risk of electric shock. Grounding screws are typically made of a conductive metal such as steel or brass, and have a green color to easily identify them as grounding components. They usually feature a pointed or self-tapping design to ensure a good electrical connection when screwed into the metal box. When installing a grounding screw, it's important to make sure that the surface of the metal box is clean and free of any paint, rust, or other contaminants that could interfere with the electrical connection. The grounding conductor, which is typically a bare copper or green insulated wire, should be securely attached to the grounding screw. This can be done by looping the wire around the screw and tightening it firmly, or by using a crimp-on connector that is specifically designed for grounding applications. It's essential to follow the requirements outlined in the National Electrical Code, or NEC, which provides detailed guidelines for grounding electrical systems. The NEC specifies the size of the grounding conductor required for different circuit sizes, as well as the methods for bonding metal enclosures and equipment. Bonding refers to the process of connecting all metal parts of the electrical system together to create a continuous electrical path. This helps to ensure that all metal parts are at the same potential, reducing the risk of voltage differences and electric shock. In addition to grounding screws, other methods can be used to ground metal electrical boxes, such as grounding bushings and bonding jumpers. Grounding bushings are used to provide a smooth and rounded surface for the grounding conductor to pass through when entering or exiting the metal box. Bonding jumpers are short lengths of wire that are used to connect different metal parts of the electrical system together. Regardless of the method used, it's crucial to ensure that the grounding connection is secure and reliable. A loose or corroded grounding connection can increase the impedance of the grounding path, which can reduce the effectiveness of the grounding system and increase the risk of electric shock. Therefore, it's important to regularly inspect and maintain grounding connections to ensure that they are in good condition. The NEC provides specific requirements for the inspection and testing of grounding systems. These requirements are designed to help identify any potential problems with the grounding system and ensure that it is functioning properly. When working with electrical systems, it's always important to follow safe work practices and use appropriate personal protective equipment, such as insulated gloves and safety glasses. Electricity can be dangerous, and it's essential to take all necessary precautions to prevent electric shock and other injuries. Grounding is a critical aspect of electrical safety, and it's important to have a thorough understanding of the principles and practices involved. By following the requirements outlined in the NEC and using appropriate grounding methods, you can help to ensure the safety and reliability of electrical systems. If you're unsure about any aspect of grounding, it's always best to consult with a qualified electrician. Firstly, grounding screws are a fundamental component in ensuring electrical safety within metal enclosures. Secondly, they serve as the primary connection point for the grounding conductor, which plays a vital role in diverting fault currents. Thirdly, proper installation and adherence to the National Electrical Code are paramount for effective grounding. One must ensure the grounding screw is securely fastened to a clean, uncorroded surface on the metal box to establish a low impedance path to ground. 2. The grounding conductor should be properly sized according to the circuit's amperage rating as specified in NEC Table 250.122. 3. The conductor must be tightly connected to the grounding screw, often using a crimped connector or a tightly wrapped loop. Grounding is a critical safety measure in electrical systems, designed to protect individuals from electric shock and prevent damage to equipment. It establishes a low resistance path for fault currents, allowing them to quickly return to the source and trip a circuit breaker or fuse, thereby de-energizing the circuit. This process ensures that metal enclosures of electrical equipment remain at a safe potential, preventing them from becoming energized in the event of a fault. The National Electrical Code (NEC) provides comprehensive guidelines for grounding and bonding electrical systems, outlining specific requirements for conductor sizing, installation methods, and equipment grounding techniques. Compliance with the NEC is essential for ensuring the safety and reliability of electrical installations. Grounding screws, typically made of green-colored metal, are used to connect grounding conductors to metal enclosures, providing a direct path to ground. These screws must be securely fastened to clean, corrosion-free surfaces to ensure a reliable electrical connection. Grounding bushings are often used in conjunction with grounding lock nuts to provide a smooth, rounded surface for grounding conductors to pass through when entering or exiting metal enclosures. Bonding jumpers are used to connect metal parts of an electrical system together, creating a continuous electrical path and ensuring that all metal components are at the same potential. This helps to minimize voltage differences and reduce the risk of electric shock. Equipment grounding conductors (EGs) are used to connect metal enclosures and equipment to the grounding system, providing a low impedance path for fault currents. EGC can be either bare or insulated and must be sized according to the circuit's overcurrent protection. Ground fault circuit interrupters (GFCIs) are designed to detect even small amounts of current leakage to ground and quickly de-energize the circuit, providing an additional layer of protection against electric shock. GFCIs are commonly used in areas where there is a high risk of exposure to moisture, such as bathrooms, kitchens, and outdoor locations. Regular inspection and testing of grounding systems are essential for ensuring their effectiveness. Grounding connections should be visually inspected for corrosion or damage, and grounding impedance should be tested to verify that the grounding path is intact and has a low resistance. Firstly, understand the code requirements. The National Electrical Code, or NEC, provides specific guidelines for grounding and bonding electrical systems. It's essential to be familiar with these requirements to ensure that your electrical work complies with safety standards. Secondly, choose the right materials. Select grounding screws, conductors, and other components that are appropriately sized and rated for the specific application. Using the wrong materials can compromise the effectiveness of the grounding system. Thirdly, prepare the surfaces properly. Before making any grounding connections, ensure that the surfaces are clean and free from corrosion. Use a wire brush or abrasive pad to remove any rust or oxidation that could interfere with the electrical connection. Fourthly, make secure connections. Tighten all grounding screws and connectors securely to ensure a reliable electrical connection. Loose connections can increase resistance and reduce the effectiveness of the grounding system. Fifthly, test the grounding system. After completing the grounding installation, use a multimeter or ground impedance tester to verify that the grounding path is intact and has a low resistance. This will help to ensure that the grounding system is functioning properly and providing adequate protection against electric shock. Sixthly, maintain the grounding system. Regularly inspect grounding connections for corrosion or damage and replace any components that are worn or deteriorated. Proper maintenance is essential for ensuring the long-term effectiveness of the grounding system. Remember that grounding is a critical safety measure in electrical systems. Taking the time to do it right can help to protect yourself and others from electric shock. Grounding is the process of creating a low-resistance path for electrical current to flow back to the source in the event of a fault. This path allows the overcurrent protection device, such as a circuit breaker or fuse, to quickly trip and de-energize the circuit, preventing electrical shock and equipment damage. The grounding system consists of several components, including the grounding electrode, grounding conductor, and equipment grounding conductor. The grounding electrode is a metal rod, pipe, or plate that is buried in the earth and connected to the grounding conductor. The grounding conductor connects the grounding electrode to the neutral busbar in the electrical panel. The equipment grounding conductor connects the metal enclosures of electrical equipment to the grounding system. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. This ensures that all metal parts are at the same potential, reducing the risk of voltage differences and electric shock. Bonding dampers are used to connect metal raceways, enclosures, and other metal parts of the electrical system. The National Electrical Code, or NEC, provides specific requirements for grounding and bonding electrical systems. These requirements are designed to ensure the safety and reliability of electrical installations. The NEC specifies the size of the grounding conductor, the type of grounding electrode, and the methods for bonding metal parts of the electrical system. It's important to follow the NEC requirements when installing or modifying electrical systems. Grounding and bonding are essential for electrical safety. By providing a low resistance path for fault current and ensuring that all metal parts are at the same potential, grounding and bonding help to protect individuals from electric shock and prevent damage to equipment. Grounding electrical boxes is crucial for safety. When a fault occurs, the metal box can become energized. Proper grounding provides a low resistance path for the fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. This prevents the metal box from becoming a shock hazard. There are several methods for grounding metal electrical boxes. The most common method is to use a grounding screw. The grounding screw is a green-colored screw that is specifically designed for grounding purposes. It is typically located inside the electrical box. To ground the box, you simply attach a grounding wire to the grounding screw and tighten it securely. Another method for grounding metal electrical boxes is to use a grounding clip. Grounding clips are small metal clips that are designed to snap onto the edge of the electrical box. They have a hole for attaching a grounding wire. To ground the box using a grounding clip, you simply snap the clip onto the edge of the box and attach a grounding wire to the clip. Some electrical boxes have a pre-drilled hole for grounding. This hole is typically located on the back or side of the box. To ground the box using this hole, you simply insert a grounding screw into the hole and tighten it securely. The grounding wire should be connected to the grounding screw before it is inserted into the hole. When grounding metal electrical boxes, it is important to use the correct size grounding wire. The size of the grounding wire is determined by the size of the circuit that the box is protecting. The National Electrical Code, or NEC, provides tables that list the correct grounding wire size for different circuit sizes. It is also important to make sure that the grounding wire is properly connected to the grounding screw or clip. The connection should be tight and secure. Loose connections can cause the grounding system to fail. Finally, it is important to test the grounding system to make sure that it is working properly. This can be done using a multimeter. The multimeter should read close to 0 ohms between the metal box and the grounding electrode. If the multimeter reads a high resistance, then the grounding system is not working properly and needs to be repaired. Grounding is an essential part of electrical safety. By properly grounding metal electrical boxes, you can help to protect yourself and others from electric shock. Grounding provides a safe path for electrical current in the event of a fault, protecting people and equipment.